You ever stop and think about what's going on inside your walls? There's this whole silent language being spoken by wires. Today, we're going to decode it. This is the system that keeps our world powered and, keeps us safe.
Okay, let's just try a little thought experiment here. Picture this. An electrician opens up a panel, right? And inside, it's just a total mess of identical gray wires. No colors, no labels, nothing. How in the world do they figure out which one's going to light up a room and which one's going to light them up? Yeah, one wrong guess, that's not just a mistake, it's a potential disaster. I mean, can you imagine? It'd be absolute chaos, pure danger. Every single switch, every outlet, it's all hooked up to this completely unpredictable grid. Just trying to do something simple, like changing a light fixture. Suddenly, it's a game of Russian roulette. No thanks.
Thankfully, we don't live in that world. And the reason is a standardized system called the National Electrical Code. You'll hear it called the NEC. Just think of it like a universal language for electricity. It means an electrician in, say, California can look at the exact same panel as one in Maine, and they both know exactly what they're looking at. It's all about creating safety through clarity.
All right, so here's the plan for today. We're going to start with the basics, kind of like the ABCs of wires, the three main jobs they have. Then, we'll see how things get a little more complicated with different power systems, AC versus DC. And finally, we'll finish up with something that sounds boring but is maybe the most important part of all, documentation. All right, let's jump in. First up, you've got to understand that every wire has a specific job. They're not just interchangeable pieces of metal. Each one is a specialist. Okay, so first we have the grounded conductor. You've probably heard this called the neutral wire. The best way to think about it is like this. If electricity is a delivery service, the neutral wire is the return path. It's the road the truck takes to get back to the warehouse after it's dropped off its package of power. It's what completes the circuit, letting everything flow. Then you've got the equipment grounding conductor. Now this one's different. It's not part of the everyday flow of electricity. It's your bodyguard. It's a dedicated safety line that connects the metal parts of your appliances, like the casing of your toaster or washing machine, straight to the ground. So if something goes wrong and a hot wire touches that metal, this guy jumps into action, safely shunting that dangerous current away from you. It's literally a lifesaver. And last but not least, the ungrounded conductor. Everybody just calls this the hot wire. Going back to our delivery analogy, this is the delivery truck. It's carrying that package of energy, that juice, from the source right to whatever you've plugged in. This is the one doing the heavy lifting. Okay, so we've got the basics down. But what happens when things get more complicated? In a regular house, you've probably got one system. But think about a big building, like a hospital or a factory. They might have multiple AC voltage systems running side by side. One for the lights, another for massive machinery. How do you keep from mixing those up? Because that would be bad. Well, the NEC has a really straightforward, logical process. First, you just confirm, yep, we've got more than one system here. Second, you have to identify every single one of those hot wires, not just that it's hot, but which system it belongs to. And the third step is absolutely crucial. You have to post a key, a legend, explaining your whole identification system right there on the panel, so anyone who opens it knows the code. And this is what's so smart about the code. It's practical. It doesn't say, you must use this one specific method. Nope. Electricians can use separate color coding, they can use marking tape, tags, whatever works. The point isn't how you do it. The point is that you do it, and you do it clearly and consistently so there's no confusion. All right, let's switch gears a bit. Let's talk about DC, or direct current. This is the kind of power you get from solar panels, batteries, that sort of thing. With DC, the rules change. We're not talking about phases anymore, like with AC. The whole game here is about one simple but critical idea. Polarity, positive and negative. And when it comes to DC systems, the rules get super specific, especially for the smaller wires, the ones you see all over the place. For these common conductors, the code is black and white. There is zero room for guessing. So check this out. It's pretty simple. Positive wires have to be marked with red. That could be the whole wire, a red stripe, or even just a plus symbol printed on it. And for negative, it's got to be black. Same deal, the whole wire, a stripe, or a minus symbol. This isn't just for looks. If you accidentally reverse the polarity, you can fry expensive, sensitive electronics in a heartbeat. So this rule is a big deal. And just like any good language, the language of wires has reserved words, colors you just can't use for anything else. The code is really strict about this.
Green is always for the equipment ground, always. And white or gray, that's always for the neutral. By keeping these colors sacred, so to speak, the code eliminates any chance of confusion and keeps the whole system easy to understand and, most importantly, safe.
Okay, so we've got the different jobs for wires, we've got colors, we've got markings. It seems pretty complete, right? But the NEC adds one last layer, and it's maybe the most important one for making sure this whole system actually works long-term.
This part of the code is all about making the system last. It basically says that the key to your color coding, your language, can't just be something the first electrician remembers. No way. It has to be physically written down and posted permanently, right there at the panel. It creates a permanent record for anyone who ever works on that system.
And think about what that does. It turns what could have been one person's knowledge into a living, breathing safety document for everyone. It means that 10, 20, 50 years from now, another electrician can walk up to that panel, look at the legend, and instantly understand everything. They're safe, and everyone in the building is safe. It's about future-proofing safety. So, the next time you flip on a light switch, just take a second. Remember that you're tapping into this silent conversation that's happening inside your walls. The National Electrical Code, it's not just some dry rule book. It's the grammar that makes that conversation work. It's a language of safety, and it's being spoken all around us all the time. The real question is, are you listening?